Let's talk about a field study where researchers track knifefish with electrode array. Typically, research requires tagging to properly track fish, but because of the weak electric discharges that knifefish produce, researchers have a unique opportunity to track them without tagging them. By utilizing submerged electrode arrays and tracking algorithms for these fish, they were able to monitor 3 different species of knifefish throughout their native range. They were able to discern the species of knifefish based on their harmonic resonance and frequency from the electric discharge from their organs. Utilizing this technology, they're able to track knifefish throughout their native range. Researchers found some interesting results by monitoring these fish using this method. Thankfully, each type of knifefish produced a different frequency of electric discharge, which allowed researchers to track individual species throughout the day. Because they were able to track individual species, they were able to figure out that different species regularly swim in close proximity to each other throughout their day. When this happens, the lower frequency species raises their harmonic resonance to match the higher frequency species. This is often seen as dominance behavior and a way to ward off attacks from other fish. Now for some findings from this study. The researchers in this study saw that all 3 species of knifefish were seen performing upstream movement during the first half of the night, followed by downstream movements in the second half of the night. Researchers discerned that S. styriensis and E. humboldti show a strong preference for swimming along the root masses of trees, which are on the periphery of the river, when moving upstream. This may be because the water is slower on the riverbanks, or it could be because potential prey items live near the riverbanks. When moving back downstream, it was observed that they stay away from the undercut bank and stick to slower moving waters. Neither during upstream movement or downstream movement were they observed swimming in the main river channel where the current is typically higher. It also appears that during the day they stay in deeper water, while at night they move to shallower water. This could be for protection and hunting behavior. But overall, this field study was a success. Because of it, we were able to see that we can accurately track knifefish using electrode arrays and a specialized tracking algorithm. Though something that made tracking the knifefish easier in this study is that none of the knifefish had frequencies which overlapped each other. This would not be true in river systems like the Amazonian River Basin, where there are tons of species of knifefish swimming in close proximity to each other. Because of this, in other habitats it may not be possible to discern individual species.